This is the side of Mount St. Helens blowing out 45 years ago. And this is where we think the next eruption will happen, which will be in our lifetime, by the way.
The world thought it had silenced Mount St. Helens, but 44 years after the explosion that erased forests and rewrote maps, the mountain is stirring again. The United States Geological Survey has issued a red alert, the highest possible warning, signaling that one of Earth's most dangerous volcanoes may be ready to wake. Beneath its snow-covered crown, magma is rising, gas is building, and the ground itself is swelling. The clock is ticking, and scientists can feel the mountain's pulse quicken. Could the most notorious eruption in American history be about to repeat itself? The mountain wakes. At first it was just a whisper, small tremors deep below the Cascades, too faint for anyone but machines to hear. But by late spring, seismographs began to dance. Clusters of earthquakes rippled beneath Mount St. Helens, each one a heartbeat in the mountain's restless body. The frequency doubled, then tripled. To seasoned volcanologists at the USGS Cascades Volcano Observatory, the pattern was unmistakable. Magma was moving. Gas sensors stationed in the crater registered sudden spikes in sulfur dioxide and carbon dioxide, chemical signatures that betray molten rock rising toward the surface. High-resolution satellite imagery revealed subtle swelling of the summit, barely a few centimeters at first, but spreading outward like a slow breath. Thermal cameras caught pockets of heat around fumaroles, where steam hissed through vents that had long lain dormant. The mountain that had slept since 2008 was breathing again. Inside the observatory in Vancouver, Washington, analysts pored over data streams in silence. They had seen these patterns before, though never identical. Each volcano speaks its own language. St. Helens communicates through quakes that start deep and climb upward, through gases that pulse in rhythm with subterranean pressure, through minute deformations of rock that computers can measure, but the eye cannot see. When these signals converge, there is only one responsible course of action: raise the alert. And so, after weeks of escalating activity, the USGS raised Mount St. Helens to red alert, a classification reserved for an eruption that is imminent or already in progress. For residents of Washington state, it was déjà vu written in ash and memory. The official statement was calm, factual, restrained. Yet between its lines lay urgency. Scientists warned that magma had repressurized chambers beneath the crater. Volcanic gas ratios hinted at fresh magma rather than residual heat. Even ground deformation suggested inflation across several kilometers. The signs pointed not to minor unrest, but to a system loading energy for a potential explosion. For many Americans, Mount St. Helens is a symbol frozen in time, an open-jawed crater framed in snow, a national monument to destruction. But geology does not respect nostalgia. Deep below, basaltic magma rises from the subducting Juan de Fuca plate, melting crust as it ascends. This is no dormant relic. It is a living engine. Local news helicopters hovered above the mountain, catching plumes of vapor curling from the summit. Some mistook the scene for eruption smoke, but the USGS clarified, not yet. What viewers saw was steam venting from fractures widened by pressure. The volcano was flexing its muscles. Scientists compared current readings to archived data from early 1980. The parallels were unsettling. Similar depth distributions of earthquakes, similar rates of ground uplift, even comparable gas compositions. The difference was the sophistication of today's monitoring network. Back then, predictions relied on analog instruments and field notes. Today, satellites, drones, and GPS arrays capture every twitch in the Earth's crust. Still, even with advanced tools, prediction remains uncertain. A volcano is an orchestra of variables: pressure, viscosity, gas content, and conduit geometry playing in shifting tempo. One wrong interpretation, and humanity learns humility again. Is the mountain warning us, or merely reminding us that it never truly sleeps? Echoes of 1980. To understand the dread behind the current red alert, one must revisit the day the sky fell. On May 18, 1980, Mount St. Helens exploded with the force of 500 atomic bombs, In a single instant, the volcano's northern flank collapsed in the largest landslide ever recorded. The sudden release of pressure uncorked superheated gases that tore through forests at 600 kilometers per hour, flattening trees across 130 square miles. Ash darkened skies from Washington to Oklahoma. Rivers clogged with mud and timber. 57 people died, many of them scientists and photographers who had come too close in pursuit of knowledge. The event transformed not just the mountain, but the science of volcanology itself. That eruption began, as this episode does, with subtle seismic murmurs. For months, quakes rattled the region while a bulge swelled on the volcano's north flank, an ominous blister growing outward by 5 feet a day. When it finally gave way, the side of the mountain slid, depressurizing the magma chamber and releasing a blast that traveled faster than sound. Entire ridgelines vaporized. The top 1,300 feet of the peak vanished, leaving a horseshoe-shaped crater still visible today. For years afterward, the landscape looked lunar, yet from the ashes came rebirth. Scientists established the Mount St. Helens National Volcanic Monument to study ecological recovery. Lupines pushed through ash fields. Elk returned to graze among dead trunks. Nature rebuilt itself molecule by molecule, but the mountain never stopped rumbling. In 2004, a new dome began to grow within the crater, extruding lava like a giant tooth. It puffed steam and ash intermittently until 2008, then quieted, apparently content. Now, as instruments detect swelling once more, scientists recognize a familiar cycle: dormancy, inflation, eruption, renewal. For residents who lived through the original disaster, the red alert brings old memories rushing back: the thunder that shattered dawn, the darkness that turned noon to night, the grit of ash grinding between teeth. Many who were children then now tell their own grandchildren the story. They remember how fragile civilization looked beneath a sky filled with fire. Technological progress offers reassurance but not immunity. Modern monitoring can issue warnings hours or days in advance, yet once pressure exceeds the threshold, no force can stop it. The magma will find release. Whether it emerges in a slow dome-building phase or a catastrophic explosion depends on the delicate balance of gas and viscosity inside the mountain. Volcanologists analyze that chemistry like doctors reading a patient's vitals. Current gas ratios suggest magma rich in silica, which traps gases more effectively, an indicator of explosive potential. Meanwhile, deformation maps show inflation concentrated under the crater rather than the flanks, implying upward pressure rather than lateral collapse. If accurate, the next eruption might resemble a vertical column of ash rather than a sideways blast. But nature has a habit of rewriting expectations. The parallels between 1980 and now haunt every briefing. The same subduction forces still grind offshore. The same magma reservoirs refill. The same forests stand in the path. Each tremor beneath St. Helens carries the echo of that morning when the mountain tore itself apart. If history can repeat in geology, how many warnings do we truly get before the Earth demands remembrance? Science in the shadow. Inside a grey concrete building in Vancouver, Washington, a team of geologists works around the clock, their eyes fixed on a wall of screens alive with trembling lines and shifting colours. These are the instruments that let humanity hear the mountain breathe. Each red flicker marks a tremor, each curve in the data, a heartbeat in molten rock. The USGS cascades. Volcano Observatory has become the mountain's interpreter, translating seismic whispers into warnings that could save thousands of lives. The data arrive from a network of sensors scattered across the Cascade Range, GPS units anchored to rock outcrops, gas detectors perched near vents, and infrared satellites orbiting hundreds of kilometers above. Together, they form an electronic web capable of detecting movement less than the width of a coin. When the mountain exhales, this system knows. Yet, for all this sophistication, prediction remains an art balanced on science. Volcanologists must read not just numbers, but patterns. Intuition built over years of watching magma rise and fall. They compare the present to hundreds of past events stored in global databases. Does this cluster of quakes mimic a dome-building phase? Does this gas ratio suggest new magma or reheated residue? Every data point is a clue in a mystery with no guaranteed ending. Drones now play a crucial role. They hover over the crater, collecting thermal imagery too dangerous for humans to obtain. These machines can fly through fumes and return with microsamples of gas that reveal the chemistry of the magma below. In one recent mission, a drone captured footage of faint orange glow deep inside a vent, a sign that heat is migrating upward. Satellites contribute their silent testimony. Using radar interferometry, they measure surface deformation with millimeter accuracy. When compared over weeks, these images show the mountain's skin stretching and relaxing like a living muscle. The current sequence shows steady inflation centered beneath the southern rim, consistent with magma pressurization. This technological vigilance is born from the humility learned in 1980. Then, instruments were primitive, and communication lagged hours behind the data. Today, algorithms flag anomalies in real time, and emergency managers receive instant alerts. Still, nature resists full comprehension. A volcano may tease for months, then subside without erupting, or it may detonate with little warning. Science narrows possibilities. It cannot eliminate them. What has improved most dramatically is coordination. The USGS, NASA, NOAA, and local agencies now share data streams through a single cloud platform. Thermal anomalies, seismic trends, and gas readings merge into three-dimensional models that visualize magma pathways, like arteries pulsing inside the crust. This allows planners to simulate eruption scenarios and update hazard maps every hour. Beneath the technical calm of the command center lies a human tension. Every scientist knows that a misjudgment could cost lives or credibility. To raise a red alert too early invites panic and economic loss. To raise it too late invites tragedy. The decision is collective, the responsibility immense. Volcanology, for all its equipment, is ultimately a discipline of listening. It teaches patience, respect, and restraint. Mount St. Helens speaks in pulses of gas and quakes. Scientists answer with vigilance and humility. They know the mountain owes them nothing. When data speak in riddles and the Earth itself holds the code, how much certainty can humanity truly claim before the next roar? Communities on edge. In towns that nestle along the Cowlitz and Toutle rivers, life continues under a quiet unease. Fishermen cast lines beneath skies that now shimmer with haze. Schoolchildren rehearse evacuation drills that mirror those for earthquakes and wildfires. Everyone knows the mountain's moods are changing again. For the people of southwest Washington, Mount St. Helens is more than geology. It is identity. Generations have grown up in its shadow, measuring time by eruptions and recoveries. The 1980 blast flattened their forests, but it also forged resilience. Now, that inherited memory fuels caution. Families keep emergency kits by the door. Farmers track ash forecasts as closely as weather reports. Local officials meet daily with scientists to translate data into action plans. Evacuation routes are reviewed, shelters stocked, communication lines tested. The experience of the past taught one hard lesson: speed saves lives. When the north flank collapsed in 1980, it took less than a minute for pyroclastic flows to reach the valley. Today, sirens and phone alerts can reach residents almost instantly, but only if everyone remains connected and trusts the message. Economically, the stakes are high. The region depends on tourism, forestry, and transportation. Hiking trails, visitor centers, and scenic roads draw millions each year, yet they sit within potential hazard zones. If the alert escalates further, closures will follow, costing livelihoods even before ash begins to fall. Business owners face the same dilemma their predecessors faced 4 decades ago: wait and risk devastation, or evacuate and risk financial ruin. The psychological toll may be harder to measure. For those who witnessed the 1980 eruption, images of that day never truly faded. They remember the blinding ash, the silence afterward, the smell of sulfur and pine mingled with smoke. When they hear the word red alert, they do not think of statistics. They think of absence, of homes, of forests, of friends. Still, there is a strange pride in living near a volcano. Residents speak of Mount St. Helens with reverence, calling it she, as though the mountain were an old matriarch with a temper but also a soul. Her slopes provide fertile soil. Her rivers sustain salmon runs. Many refuse to move away, convinced that coexistence is part of life's bargain in the Pacific Northwest. Emergency managers try to balance respect with realism. They host community meetings where maps glow red and orange, showing likely paths of lava and lahars, those terrifying torrents of mud and rock that can race down valleys faster than a car. The maps are sobering, but knowledge is empowerment. When people understand the risk, fear transforms into preparation. Local media play their role too, broadcasting updates that mix reassurance with vigilance. Radio hosts remind listeners to keep masks and flashlights ready, not because panic is needed, but because readiness is wisdom. In a region shaped by rain and resilience, this measured alertness has become part of the culture. As dusk settles over the Cascades, porch lights flicker in small towns along Highway 504. Somewhere above, the mountain steams quietly, its crater glowing faintly in satellite infrared. Life goes on, farmers tending livestock, families sharing dinner, but everyone keeps one ear tuned to the news. The red alert has turned the volcano from a distant monument into a neighbor whose voice grows louder each night. When a community learns to live beside danger, does courage mean staying, or simply being ready to leave? Fire and ice. High above the crater, satellites now orbit in silent formation, their sensors tuned to capture what human eyes cannot. From these images, scientists trace faint plumes of gas curling into the stratosphere and patches of heat spreading beneath the snow. It is the same paradox that has always defined Mount St. Helens: beauty masking volatility, stillness hiding motion. The mountain glistens white in morning light, yet within that shell, molten rock climbs slowly toward the surface. If it erupts, the confrontation between fire and ice will be violent. Snowfields and glaciers that crown the summit will flash melt into torrents of mud known as lahars, capable of sweeping down valleys at freeway speeds. These flows do not discriminate. They devour bridges, bury highways, and erase river towns within minutes. In 1980, such surges carried debris 30 miles downstream, remaking entire watersheds. Today, more than twice as many people live in those corridors. Sensors now line the river channels, feeding real-time data to sirens that can trigger automatic alerts. For emergency planners, each sensor represents a heartbeat in a vast early warning system. But lahars are only one of many threats. Volcanic ash, the most far-reaching of them all, can blanket entire states. Unlike the soft ash from a fireplace, volcanic ash is pulverized glass, microscopic shards that slice through lungs, clog engines, and short-circuit power lines. During the 1980 event, aircraft hundreds of miles away reported reduced visibility and damaged turbines. If the volcano produces another column rising 10 or 12 miles high, modern air traffic could grind to a halt across the Pacific Northwest. Airports from Portland to Seattle already have diversion plans, and meteorological centers have trained radar to track potential ash clouds in real time. Scientists also study the atmospheric implications. Large eruptions can loft sulfur dioxide into the stratosphere, forming reflective aerosols that scatter sunlight and temporarily cool the Earth. After Mount Pinatubo erupted in 1991, global temperatures dropped by nearly half a degree Celsius for 2 years. Mount St. Helens, though smaller, could still nudge regional climates, altering rainfall and dimming summer skies. For climatologists, this prospect turns the red alert into a laboratory of global feedback loops, how a single mountain can whisper across hemispheres. Closer to home, ecosystems stand at a fragile threshold. The blast zone that once resembled a wasteland has, over 4 decades, become a mosaic of recovery. Young forests stretch where ash once smothered the soil. Rivers host salmon again. Elk herds roam the meadows. Another eruption would test that resilience. Ash could collapse canopies, suffocate streams, and reset succession all over again. Yet, paradoxically, such destruction also sows the seeds of renewal. Volcanic minerals enrich the soil, triggering explosions of plant growth once the dust settles. Nature has always turned ruin into regeneration, and Mount St. Helens remains one of the clearest theaters where that cycle unfolds. From an engineering standpoint, every eruption forces innovation. Power utilities design transmission towers that can bear the weight of ash. Architects in nearby towns plan roofs with steeper slopes for quicker shedding. Farmers study crop varieties that can tolerate acidic dust. The region has learned to coexist with uncertainty through design as much as through courage. Meanwhile, inside the volcano, pressure keeps building. Instruments show magma rising at roughly 2 meters per day. Slow, steady, relentless. The chemistry suggests a mix of andesite and dacite, viscous and gas-rich, the recipe for explosive eruptions. Volcanologists model the potential outcomes: a dome-building event that oozes lava for months, or a sudden Plinian eruption that sends ash into the stratosphere within minutes. Both are plausible. Neither can be dismissed. Across the Pacific Northwest, people watch the mountain as if reading the mood of a living being. Each tremor becomes a sentence, each plume a whispered word. Yet the story remains unwritten. Humanity stands, as always, between awe and anxiety, aware that the next chapter could change everything. When the balance between creation and destruction narrows to a single trembling moment, will we witness renewal or reckoning? The unfinished Earth. Volcanoes remind us the planet is still being made. Beneath continents and oceans, heat rises from a heart that never cooled. Mount St. Helens is one outlet among many, a place where human memory meets geologic time and every tremor echoes an ancient rhythm. Here, the Juan de Fuca Plate slides beneath North America along the Cascadia boundary, melting rock and driving magma upward through fractures. That slow engine built the Cascades from Rainier to Shasta. To live here is to stand at the edge of creation. An eruption is the earth breathing. Each blast vents gases trapped for ages and returns minerals to the crust. The same force that threatens life also sustains fertile valleys and, ultimately, our atmosphere. That is the deeper meaning of a red alert. It is not only danger, it is proof the Earth is alive. Across the Northwest, observatories track every vibration. Models test plume scenarios hour by hour. Students, scientists, and residents learn together that mountains keep their own calendar. Communities have turned knowledge into resilience. Classrooms teach volcanic science. Museums preserve ash and stories. Visitors gather at Johnston Ridge, where David Johnston's final words still stand for duty and witness. Whatever comes next, the message endures. Motion is the rule. Safety is vigilance. People adapt. They rebuild. They stay. Mount St. Helens remains an unfinished sentence. Steam becomes commas. Tremors become heartbeats. Eruptions become chapters. Our task is to read the story with care and prepare for the next page. When the ground beneath our feet becomes a voice instead of a foundation, will we finally learn to listen? The red alert stands as both warning and invitation to prepare, to learn, to remember that we share this planet with forces far older than ourselves. Mount St. Helens may erupt tomorrow or a decade from now, but its message has already arrived. The Earth is awake, and it is speaking. Stay curious, stay ready, and stay respectful of the ground that holds us all. If you found this story as powerful as the mountain that inspired it, subscribe for more deep dive documentaries about the living Earth. Because somewhere beneath our feet, another story is already beginning, and when it breaks the surface, you'll want to be here to witness it first.